Welcome to another video. In this video, we want to learn about sequences and series, and we're finally going to do the proof of a geometric series. So now we already learned that Tn equals to ARn minus 1. This is the formula that we use to work out any term of a geometric pattern or sequence. We can also use this to work out any term for a geometric series, right? So if I want term 1, we understood that it will be term 1 is the a value, and then term 2 will be the a value times r. Term 3 will be the a value times r squared. As you can see, the r's are evolving, so term 4 will be something like a times r3. Okay, so always one less than what the term is, because you always subtracting one. Now the formula we use to work out any random term is obviously a times r to the power of n minus 1. But if I wanted a term behind this one, I would say it's a times r to the power of n minus 2. The term behind that will be a times n times r to the power of n minus 3. So that's how I would get the terms. But then now we want to learn about the series. So the series is the sum of. You have to add all these terms. So what would be a formula that we can use to work out the sum of a geometric series? So let's formulate it. Well, we say the sum of, we have to take the first term, add it with the second term, add it with the third term, and so forth, right? Until we add these random terms, whereby I'll add the term a times r to the power of n minus 1, and the term behind this will be a times r to the power of n minus 2, right? So it just continues that way, right? And then what I would like to do is just multiply this equation by r. So I'll say r times Sn. What does it give us? This first term will now be multiplied by r to form ar. The second term will be multiplied by r to form ar squared, and so forth. So you can see that this term forms the second term, that term forms the third term, that term forms the next, and so forth and so forth. So over here, the term previous to this, which is this one, if you multiply this by r, we obviously know that you need to add, say, minus 3 plus 1 will give you minus 2. So we have a to the power of a times r to the power of n minus 2. When you multiply this one, it will give us a times r to the power of n minus 1. And when you multiply this one, it will give us a times r to the power of n, because the ones will actually cancel out. So that's what we're going to have after you multiply it by the r. Now what you want to do with these two equations is subtract them. So when we subtract, we're going to say, therefore, I have Sn minus r Sn is equals to. The a has nothing to subtract with. There's no common like term for it. So we're going to write down the a. The ARs are going to cancel out. These guys are going to cancel out. All of those are going to cancel out, except for that one where we have minus ARN. So this is what we have left after we subtract those two equations. Now we want to factor out the Sn on the left hand side. We factor out the Sn, we get 1 minus r is equals to. Factor out the a, we get 1 minus r to the power of n. So that's what we have here. Then we want to take this bracket to the right hand side. It's multiplying here, it will divide on the other side. So we have Sn is equals to a 1 minus r to the power of n all over 1 minus r. So I don't have to put the brackets there anymore. I can just remove them. All right, so this is the formula we are going to use to work out the sum of a geometric series. Now it's important to note a few things here. Firstly, r cannot be 1, because if r is 1, that means that your denominator will become 0. That means this whole thing will be undefined. So you can't have a constant ratio. R is your constant ratio, by the way. So you can't have a constant ratio 1 and use this formula. It's not going to work. Also, we like to use this formula when r is smaller than 1. So if r is a half, is a third, is a negative number, we like to use this formula as it is. But if r is now bigger than 1, we like to use, let's say we take out a negative. If you take out a negative there at the top in the brackets, you're going to get minus a bracket. Let me write the Rn. The Rn is now going to be positive while the 1 becomes minus. So take out a negative there at the bottom as well. We get the R being positive and we get the 1 being negative. So I took out a negative and these negatives are actually going to cancel out. So the formula that you would like to use when R is bigger than 1 would be Sn is equals to A bracket Rn minus 1 over r minus 1. Both of them are the same. It's just that we took out a negative for this one and we didn't take out a negative there. So if r is bigger than 1, it's preferred that you use this formula. Your sum will be easier. But if r is smaller than 1, it's preferred that you use this one. Remember, r cannot be positive 1, because if that happens, then this whole thing is undefined. That's it for this video, guys. I hope you enjoy. We will see you in the next one.